So in this video we will study about the half-life of the reaction. Half-life, what is the meaning of half-life? So this is the definition. Half-life, the time required for the concentration of a reactant to decrease to half of its initial value. So suppose we can understand this with this graph. So this graph is the concentration of reactant in the y-axis is plotted like 0 to 100, and time is from left to right is increasing. So if you notice here in this graph, bar graph, first bar shows the 80%, means the concentration of A is 80%, and after 12 seconds its concentration decreases to 40. Further, after 12 seconds its concentration decreases to 20. Further, after 12 seconds its concentration decreases to 10. So you can see every 12 seconds the reaction concentration is becoming half. So in this process, this time is called half-life of this reactant concentration is 12 seconds, because after every 12 seconds the reactant concentration is decreasing to half. So this is the first half-life, and after second half-life it will become 20%. After third half-life it become 10%, and after fourth half-life it become 5%, and after sixth half-life 1 2 3 4 fifth, after fifth half-life this will become 2.5%. so every half-life the reactant concentration will decrease to half. This was also explained through this graph. You can also figure it out. What is the molarity at this point? Suppose this point is molarity is 75, or it was here like 150 to 75 and then 37.5. so how much time it is taking to go from 75 to 37.5? that time is called the half-life. So let's see how we calculate the half-life from the graph. And so half-life of the first order reaction, derivation of half-life. Since in case of half-life, initial concentration A0 will be initial concentration, and the half-life means T half is when. So after half-life what will happen? Basically AT, the concentration of AT will become half of the initial. So this is AT means half-life, after half-life. So we have seen that according to first order reaction, this is my first order reaction, natural log AT is equal to minus KT plus natural log A0. So after half-life what will happen? After first half-life what will happen? So we can replace this T as a T half. In this equation we are replacing the T as a T half, and then initial concentration will not change, natural log A0 will remain same, but the concentration after half-life will become half of the initial concentration. So we can replace AT in the form of 1 over 2 initial concentration, right? So after first half-life AT will become, the concentration will become half of the first one. So then what? We can rearrange this equation to move all the natural log terms into one place on the left hand side. So what we did, basically we move plus natural log a0 from right side to left side, and once you will move, it will become negative natural log, and then the other side will become minus k and t half. Then what we can do, if you remember the math for the log, then when we subtract the two log value, basically we can divide them. So we can also write this equation as natural log half of initial concentration divided by a0, or initial concentration will be negative t half on the other side, where a0 and a0 we can cancel now. So what will remain on this side? This side it will remain only natural log half is equal to k and t half. So we can take a negative on both sides. So this side, left side will become negative, and then right hand side, this negative will become positive. Now if you will take the natural log of 2, 1 over 2. So let's take the natural log of in the calculator. So let's clear first. If you will type the natural log 1 over 2, no sorry, I did wrong. We can do like this one, 1 natural log 1 divided by 2 parenthesis close and then enter. So here you can see the answer will come negative. So once you will open that parenthesis, this will become also positive. So 0.693. So the relationship we can get it from this equation t half, that if you know the half-life, we can calculate the rate constant, or if you know the rate constant, you can get the half-life of the equation. So this was the derivation of equation, that how we can get the relationship between the half-life and k. So for the first order process, then the half-life does not depend on the initial concentration. So whatever the initial concentration will be there, half-life don't change. If you have 1 gram, after first half-life it will become 0.5 gram. If you have 1 kilo of initial reactant, after first half-life the reactant will become half a kilo. So in next video we will study about a few questions related to first order reaction and to calculate the t half and k.